Okay, so the next thing that we're going to do is we're going to talk about segment routing within the scope of a basic example. Hopefully my CLI is going to behave today and segment routing is actually going to work. And this goes back to a question that I just got where the question was, let me see here, it says from a software perspective. Okay, from a software perspective, do we need to upgrade the iOS version to enable segment routing? Yes. This is a very new feature. Most platforms do not yet support segment routing. Typically, in a real deployment, the only boxes you would really need to have segment routing would be on your ASR 9Ks and your carrier routing system, your CRS. Because realistically, you don't have a 2901 router or whatever in the core of your MPLS network. You would have something like that on the edge of the customer, and that device does not need segment routing intelligence. So 99.9999% of the time in a real design, you would see this running on iOS XR, or you would see it running on JunoOS. Because in reality, there's two boxes that route the core of the internet: Cisco iOS XR and JunoOS. There might be some other players in there, but we all know at the end of the day who is in MPLS core. It's Cisco and Juniper, right? So if they say we're going to do segment routing, everybody's going to do segment routing. Okay, that's ultimately the key. And if you guys know historically, what was the protocol that we, well, not even that, but there's another protocol that is called Lisp. Okay, the Locator Independent Separation Protocol. Lisp is a great idea. I have no idea why no one is running Lisp today. Actually, I do. What is the reason? Juniper did not get on board. It's a standardized protocol, but they said, no, we're not doing this. So ultimately, no, Lisp is not going to take off, because Cisco does not own the internet. Juniper's in there, and there's other players in there. But if in IETF they get together and say, hey, we're going to do segment routing as a standard, and I'm on board because you already support my data plane format, the only thing that's changing is the control plane, well, that's a different story. Okay, something like Lisp is a whole new routing paradigm. That would be immensely impossible to try to implement that at scale on the internet. We're basically saying, take something like DNS, this is now your routing protocol. That's Lisp. That's not segment routing. Segment routing is just normal routing. The only thing we're doing is changing what's going on in the core. Does ISIS support segment routing? Does OSPF support segment routing? That's all that we need to know. Okay, so the next thing that we want to look at is what does the network look like when you're not using segment routing? Okay, in this case, this is going to be an example of an MPLS Layer 3 VPN or an L3 VPN. The goal of this topology is that we have two different customer sites. We have the network connecting to router 6, we have the network connecting to router 7. So let's say, for example, these are different retail offices of some sort of retailer. They need to send traffic east-west between the sites. They also need to send it to their data center. So we're going to sell them transport. We're going to say, hey, you don't want to use the internet for transport, right? Internet is unreliable. I'm going to sell you a service level agreement. You're going to run a routing protocol with me, and I will give you site-to-site communication. Now, from the customer's point of view, they don't necessarily care about what's going on in the MPLS core. The only thing they really care about is, do I have transport? Okay, and we can see here, basically the only thing that I've tested up to this point is from router 6, I did a ping to 7777, which is the loopback of router 7, and we see that we do have IP transport. Okay, next thing we're going to do is a trace route. So from router 6, we're going to trace route to 7777. Source is 6666. This is a loopback to loopback ping or trace. Okay, the key here that I want to know is what happens when the packet exits to the service provider. The service provider is running MPLS in this case. Okay, notice from this design we have multipath. So from router 6, if we look at the show IP route for 7777, it says that I have two equal cost paths. We're learning these paths from OSPF internal routing. These are inter-area routes. Those would be the OIA status code in the routing table. So in this case, we're basically using OSPF as a hop count. So on the right-hand portion of the network, we have router 7 that is advertising its loopback 7777. This is being advertised to XR3 and to router 3 through OSPF. Okay, OSPF in this case is the to CE routing protocol. Once it gets to the edge router or the provider edge, the PE, lands on router 3, lands on XR3, they need to convert this between protocols. They're going to be redistributing between OSPF and BGP. The reason why is that the OSPF process that we're running between routers 1, 2, and 3 in the core, it's not the same OSPF process as we're running with the customer towards the edge. They're two separate routing tables. So we might have a case where we're running we're running OSPF to the edge. Okay, so between router 3 and router 7, we're running OSPF. We're also running OSPF internally, like between router 2 and 3, but these are different spaces. Okay, we do not redistribute between them. They have no reachability information about each other. Instead, what we're doing is taking the edge routes and we're ejecting them into BGP. Specifically, address family is going to be VPN version 4 or IP version 4 labeled, VPN labeled unicast, excuse me, not regular labeled unicast, this would be VPN labeled unicast. Okay, so what I mean by this is that if we were to go to the provider edge router, which in this case is router 3, and on router 3 we say show VRF to show our virtual routing and forwarding instances, or what are our routing tables, we see routing table B. We're going to show IP route for VRF-B as in Brian, and we see that we're learning an OSPF route 7777. Okay, this is coming from the PE to CE protocol, which in this case is OSPF. We now take this from the VRF aware OSPF process, because in this case this is for routing table B as in Brian. If we show run section OSPF or BGP, we should see that under the OSPF process we have a VRF aware config. So we have VRF-B and for Brian for process 100, which is technically different than the underlying OSPF process, router OSPF1. This is the process that is being used to establish the underlay. So again, the underlay is going to be the internal transport of the service provider network between its own edge routers. In this case, the underlay would be established between router 1 and router 3. So from router 3's point of view, if we show IP route, we would see that in the core of the network, we should be learning about IGP routes. Okay, we have a route to router 1, to router 2, to router 3, to router 11, 12, and 13. Okay, those are R123 and XR123 respectively. But in any case, the point of this is that we have two different routing tables. We have a routing table towards the core, we have a routing table towards the customer. We do not redistribute between them. They do not have any reachability to each other. So, from router 3's point of view, this means that in the global table, if I was to ping 7777, and we look at where is router 3, okay, router 3 is directly connected to router 7 on the right, but notice it does not have reachability to that in the global table. Okay, this is the expected result because we have an underlay and we have an overlay. The overlay is in the VRF, in VRF Brian. It says if you want to reach 7777, there's going to be some sort of other magic that's happening behind the scenes in order to connect this data plane. Okay, for example, if we were to go over towards router 1 and do the same thing, we look in the global table and say, well, how do I get to 7777? The underlay does not know about this. But what are the overlay tables? I have VRF-B as in Brian. Do I know the route to VRF-B to 7777? Yes, I do. It says the exit point out of the service provider network is the hop 3333, and MPLS is required in order to reach that destination. Okay, what this now means is that we're going to create a label stack of two labels. What we call the transport label that's going to get us towards the intermediate destination, which is 3333, and then a second VPN label that's talking about the final destination, which is 7777. Okay, before we go any further, now let's look at this from a data plane capture point of view. So what we now want to do is pick a spot in the core. We're going to pick router 2, if I can find my pen here. We're going to capture frames on all interfaces of router 2, capture traffic on all interfaces of XR2, and then we're going to forward frames through the core.